Okay, as you can see, there's a lot of things we're going to actually have to discuss about inverse functions. But the very first one, and the most important, is the notation. Now, the ordinary notation for a function, for example here, is given by a equals f of t. At least that's going to be with the example we just have. Right? And what does that usually mean? It means f is a function, we can think of that as a formula. It's doing something to t, and the answer we're calling a. Now, the best notation for inverse function, and I've actually done some research on this, is to write down that t equals f inverse of a. Now, what does that mean? This is what we want to think. Whatever f did to t to get a, f inverse is the thing that undoes to a to get our original t back. Now, we're going to see a lot of examples about this semester. Sometimes there's formulas, sometimes there's not. For things like logarithms and inverse trig functions, the only thing we're going to have is the description, and we really want to use the notation there. Meanwhile, let's just give a nice, easy example. Let's say that a is the function that does something to t. In this case, it multiplies t by 3 in order to get a. In other words, f multiplies by 3. Now, f inverse is going to be the thing that undoes multiplying by 3. Well, what would you have to do to undo multiplying by 3? You would have to divide by 3. So, f multiplies t by 3 to get a. To undo that, f inverse divides a by 3 to get our original t back.